A good number of years ago, when I had a larger mill, I decided I was tired of tramming the vise jaws to see if they were parallel to the mill table. This is the vise that I'm talking about is right here, and I'll get the camera a little closer to show you what I did with it. I turned the vise upside down, and I used these vise jaws. I put them into the slots on the mill table, which were larger slots than what I have in the mill, that I had in that mill than I do have now. And I clamped these jaws up and assumed that the vise jaws would now be parallel to the table, which may have been a mistake. And after doing that, I drilled a couple of holes here, drilled and reamed, to accept a 1/4 inch dowel pins. And we're going to take a look at the table we have now. Now the slots here on this smaller table, I can't get the vise to go in them, but the holes are already in my vise. The holes are already drilled. So the first thing I wanted to do is find out just how parallel these surfaces inside here, how parallel are they to the actual travel of the table. So I set up an indicator and I ran it across all the way from one end to the other, and although it varied about a thou, which I thought was really good for an inexpensive mill, it stayed within a thou. Now I discovered that the pins I had in the vise, the holes I'd put in there, weren't really perfect. So I needed a way to adjust those pins so they would be right, so that I could adjust them to fit in this mill, on this mill table. What I decided to do is leave this pin in and remove this pin and tap this hole with a 5/16 tap. Then I kind of roughed up this. This is not very accurate at all. I'm going to put a taper on this. This is a 5/16 Allen screw. And I screwed this in from underneath here. So this is what it looked like with the pin I made and the pin that I originally had in it. Now when I turn this screw underneath here, this moves up, of course, and since it has a taper on it, it increases or decreases the amount of pressure that's against the side of the slot on the mill. So that would be an adjustment for the vise. And I put this on the table and tried it out. It seemed to work rather well. So the next thing I needed to do was make one of these that is nice and symmetrical and hard, because we're not going to keep it the way it is. It's moving the vise around is going to wear this out in a hurry. So here's what I did. I've got the 3/8 stock held in the rotary table, and we've taken a 60 thou thick saw and put a slot in the end. That's for the screwdriver. Okay, the 3/8 stock is in the chuck. That's the one with the slot in the end here for the screwdriver. And from this end down 1 inch and 200 thousandths, we have put an undercut in here. This is where our 5/16 thread is going to end. Now this is 3/8, so we have to reduce it down to just under 5/16 so that we can thread it from here to here. I just left that in the lathe and used a die to put the thread on here. There's approximately 1.2 inches of thread here, And the next step would be to put the taper part on. And I need to set up my compound to 5 degrees to put that on there. Okay, we've already center drilled this. We've got the 5/16 18 tap drill here, and we're going to run in about 1.5 inches deep. We'll just get that right on the edge here, and we'll take it in the 1.5 inches. All we have to do now is run the tap to the bottom of the hole, and then we'll go take it over to the mill. I use one of these things to mount the 5/16 threaded portion into the chuck because I don't want to damage the threads. This one is, I don't know, 5/16 3/8. Not sure what that is. Should be marked on the end. I can barely read that. Anyway, that's what we use to put in there. Now we're going to put the taper on, and we're set up for 5 degrees here for the taper. So here's the piece that we just made compared to our trial piece here, and the length of this taper area looks to be about the same, but they're not the same size. This one, the one we just made, get a closer look, I think we need to take more off here, but what I'm going to do is try to reduce this a little bit more, but I want to try it out first. So we'll put that in the vise and see if it's going to work. If not, we'll just take more off of this taper, and if it gets to the point, well, it will eventually get to the point where it actually works, then we can harden this part up. Well, as it turns out, there's a lot more tweaking to this than what I had thought. This taper part here, I must have tried a dozen times before I got things working right. And a lot of it depends on the shape of your mill table slots. And I'll show you what I mean by that. On this slot here, you can see there's like a chamfer. So you're actually hitting down here, not up at the table, you're hitting down there. Now on the other side of here, if we can see, there's somewhat less of a chamfer. So it depends how you're pushing your vise, if you're pushing on it or pulling on it to do your locating. So you have to consider what you're pushing on. Let's move back to the next one. See the larger, there we are. See the larger chamfer here. This is probably very similar to that one. So I imagine I could locate against this, or I could locate against this. It wouldn't matter. But if I'm going for the back end of the slots, then the chamfers are a little bit different, and I have to tweak things for that. Okay, so I've got the vise sit on the table. I've got it pushed in this direction to the back towards the wall, and I've got it zeroed. This is a 1 thou indicator. I'm going to tram to the other side and see where I'm at. 5 thou, 6 thou. So we're at 11 thousandths out. So now I'm going to adjust that screw that we made and see if I can't get it back to 0. By turning the screwdriver, we got it back very close to 0. So make sure nothing moved. We'll give it a little push again back. And we're very close to 0. So now we're going to go back the other way and see if we have repaired the situation. So we turned, that's 1.5 thou. So when we started here, we were 11th out. Now I'm going to re-zero that and move back to the other end again. And we'll set it again with the adjustment screw. Get it back to 0 again over here. And we should be really close this time. That's looking really good. Really good. Almost perfection there. So what I would do now is just lock up the lock nut on the adjustment screw, and the next time I put the vise on, it's going to be trammed for me. I've moved the vise, moved it to the end of the table. Now we're going to bring it back somewhere near where we had it. The lock nut has been tightened, and we should be able to repeat this whole thing. Push everything to the back here and wind. The camera just cut out because the SD card filled up, so we'll continue on from where we left off. We've wound in on the left hand side, we've wound into 0, and now we'll tram across and see what has changed. That's looking good. Wow, maybe a 1/10 there? That's, well, I could be happy with that for sure. Maybe 1 or 2/10 off. Looks good. When using this small nut, which used to be on the threaded part here, it was a little bit difficult to get at that with a wrench because it's inside this recess. So what I've done is I made a nut with a hex on top that fits a 1/2 inch wrench, and the bottom part of this was turned down so it fit into this channel, which is right here. And the benefit of doing that as well is that when you put your screwdriver in the slot, it can't fall out. So overall, it's much better than having the small nut.